Today's class we're going to be talking about the slope of a tangent. More specifically, how to figure out the slope of the tangent algebraically. Now before we begin, I want to start with a review in terms of reviewing slope of lines as well as lines in general. So for those of you who don't remember from grade 9, you did learn about an equation to help you figure out slope, which was y2 minus y1 over x2 minus x1 for any 2 points A and B, which are defined by x1, y1 and x2, y2. You also probably learned about 3 different forms of lines. Now, generally speaking, most of you are familiar with the first 2 forms, which is the slope-intercept form, also known as y equals to mx plus b, and then standard form, which is ax plus by plus c equals to 0. There's actually a third form that we like to call point-slope form, and that particular form helps us create the equations of lines a little bit quicker, depending on the information that you're given. So let's take a look at our first example. In our first example, it says find the equation of a line in point-slope form with a slope of -3 and passes through the point -1 and 1. Now back in grade 9 and 10 and potentially in grade 11, if I asked you to figure out the equation of a line and you knew the slope and you knew a point on the line, most of you would plug it into the slope-intercept form and then solve for your b value. What I'm going to show you now is a quicker way to figure out the equation of a line using point-slope form. So the first thing that we take a note at is we know that our slope is -3, and we know that we have a point at -1 and 1. Now we're going to label -1 and 1 as x1 and y1. So point slope form, if you take a look, it's going to be y minus y1 equals to m times x minus x1. We know the value of m, that's our slope, which is going to be -3. And then we also know about our point, x1, y1, which is what we're going to replace in here. So let's do exactly that to help us create the equation of our line. So I'm going to have y minus, my y1 is just +1, equals to, my m is -3, and then I've got x minus, now my x1 here is -1, so that's why I have it in brackets just to preserve the sign. So what I've done here is I've plugged in my slope and my point into the point slope form, and what I'm going to do is I'm going to simplify. Now x and y stay as variables so that when you simplify, your slope intercept form will have the variables y and x in it. So I'm going to get y minus 1 equals to -3 times x plus 1. I'm going to expand and simplify. I'm going to get y minus 1 equals to -3x minus 3. And then I'm just going to move the -1 over. And so that's going to simplify to give me -3x minus 2. So the slope of, sorry, not the slope, my apologies, the equation of the line that has a slope of -3 and a point at -1 and 1 is y equals to -3x minus 2. So point slope form allows you to do all of that without having to worry about figuring out your y-intercept first. So now that we've gone through a review in terms of slope as well as lines and how to represent lines, let's take a look at something that you started off taking a look at in advanced functions, and we're going to continue that discussion now. So in part 2, it says, what is a tangent? Now, I'm hoping that many of you had an opportunity to talk about what a tangent was in advanced functions. So a tangent is to a curve at a given point is basically a straight line that touches the curve at one particular point, at that given point. Why do we care about tangents? Well, when we talk about tangents, we're going to be talking about things like derivatives. Okay, so that's why we need to kind of set the stage first about talking about tangents and then lead our way into derivatives a little bit later on. And so let's take a look at this example. It says, draw the tangent line on the graph to the right at -1 and 1, and then at 2 and 4. So I'm going to start off with a tangent line at -1 and 1. So I'm just going to mark that point first, which is right here. Now you're going to be manually drawing these tangent lines. So I'm going to draw a tangent line. I'm going to use the line drawing option here, and I'm going to try to draw the best tangent line that I can draw. Okay? I think that's the best one. I think. But then I look at it and I'm like, wait, maybe I can draw an even better one. So then I go and attempt a second attempt at drawing a tangent line. So I'm like, okay, let's draw this one now. This one looks like a good attempt as well. Okay, I think I've gotten my best attempt there. The same thing, I'm going to take a look at 2 and 4 now. So point 2 and 4, that's the one here, and I'm going to try to draw my best tangent line. So for me, I'm like, okay, so let's say, I feel like this is a good tangent line. And then I look at it and I'm like, maybe I can make a better one, like I did in the last one. So I'm going to then try again to draw my best tangent line again. I'm going to draw another one, which I think, okay, this one's a little bit better. I think that this one's going to be it. But notice, there should be only one tangent line per given point on a curve. But I've managed to draw more than one. When you are trying to draw tangent lines by hand, it is very inaccurate, which is why we don't ask you to figure out tangent lines graphically. Okay? If I asked you to try to do it by hand, you would probably be doing 3 or 4 tangent lines because you would always try to find the one that looked better, just like how I did here. So then we think about, okay, so if doing it by hand and trying to graph a tangent line by hand is no good, how are we going to figure out tangent lines? How are we going to do it? And that's what we're going to look at now. As you can tell from the previous example, although you may try to draw the tangent line on your own by hand, it's not very accurate, right? I was coming up with all these different tangent lines that I could draw. So we're going to try to figure out an algebraic way to help us determine the slope of a tangent and then eventually the equation of the tangent line. And in order to do that, we're going to take a look at a series of pictures to help us envision this. So let's start off first by talking about the slope of a tangent. The slope of a tangent is said to be the limit of the slope of a secant line, where this should be changed to where B approaches A along the curve. Okay, so you're just going to change as B approaches A along the curve. So A is what we call your point of tangency, where we want that tangent line to be at. In order to figure out slope, you always need 2 points, right? You can't create slope with just 1 point. You need 2 points. So that's why we're taking a look at the secant line that's created as point B is slowly headed towards point A. So if you take a look here, this is what we're envisioning. Remember, point A is where I'd like my tangent to be, okay? Where my tangent will touch the curve. And then we are working with some point B here that's going to help us estimate that slope of our tangent, right? Because we need 2 points to create slope. So what happens when that point B starts getting closer and closer and closer to A? We get a better and better and better estimate at the slope of our tangent. So if you take a quick look here at the bottom, you're going to notice I've moved my point B a little bit closer to point A now. I'm continuing to do the same thing. I've moved point B closer to A. And again, I'm moving point B closer to A until I've gotten so close that point B is literally on top of point A. But then again, we think to that logic and we're like, well, miss, still, you need 2 points to create slope. So point B can't be on top of point A because that would mean that you only have 1 point. So what we're going to do is we're going to use this idea of point B getting closer and closer and closer to point A to help us determine the slope of our tangent line now. So in this, it says the slope of a tangent as a limit. So the slope of the tangent to the graph y equals to f of x at point, that should say at point A, where it's a and f of a, is going to be given by the following equation. The slope of your tangent, right, is equal to the limit as h approaches 0 for f of a plus h minus f of a all over h. Now, for many of you, when you look at this, you're like, I don't know how you came up with this formula, miss. How did you come up with it? So what you can actually do is, remember, slope is between 2 points. And you have, quote unquote, what I would say 2 points here. You have point A, which is a and f of a. And then you also had a point B, which was a plus h, and then f of a plus h. Now, if you remember slope, slope is y2 minus y1 over x2 minus x1. This is y2 minus y1, and then x2 minus x1. That, if you simplify, will give you the equation that I've got here that I'm highlighting. Okay. And the reason why we talk about h approaching 0, remember, at the end of the day, we're looking at the slope of a tangent, which essentially means we're looking at the slope where the line will touch the curve only at one point. So by putting in h approaches 0, it's telling the reader, hey, we're talking about a b that's going to get super, 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 super close to that point of tangency there, right? So that's why we have h approaching 0. At some point when that h is 0, we're going to be able to figure out the slope of our tangent. So let's take a look at finding out the slope of our tangent algebraically. At first, when you look at the equation, it looks terrible, it looks complicated, but I assure you, once we start doing these, it'll make a little bit more sense.